This video presents a solution to design and simulate EMI filters to speed up EMI pre-compliance processes. We will remind what is at stake for power systems when talking about electromagnetic interference. We will rapidly present the EMI root causes and share some tips to mitigate the EMI noises. Finally, we will introduce our design solution to mitigate the EMI noises. A functioning power converter is not the end of the design cycle. It must be approved for sale, and one of the tests that must be passed is electromagnetic interference. In order to pass these tests, it is important to reduce the EMI noises. EMI is a disturbance usually caused by the d over dt and the dV over dt, which respectively lead to differential mode and common mode noise. In general, the EMI noises can be reduced with the help of different parameters. In case you don't want to change the topology and modulation method, it is possible to increase the gate resistance, use a slower device, add a snubber, or minimize parasitics. If these solutions are not enough, a topology change and a modulation method are necessary. In this presentation, we introduce our design solution to mitigate the EMI noises, the EMI design suite of PSIM. This solution will allow you to design your own filter, fulfill your specifications, and analyze the EMI emission noises of your power system. The EMI design suite enables you to design EMI filters and run EMI analysis for any power converter electronic system. This suite is an add-on module of PSIM. PSIM is a simulation software specifically designed for power electronics, motor drives, and energy conversion applications. PSIM is a device positioned between a circuit simulator, such as SPICE, and a system control simulator, such as MATLAB, Simulink. PSIM includes a lot of modules, among which you will find the EMI design suite. The EMI design suite helps to avoid losing time and money by drastically reducing the number of prototypes. During the design phase, the suite helps the EMI engineers to quickly integrate and perform EMI pre-compliance testing of the system. This PSIM add-on module also allows hardware engineers to carry out hardware component selections and EMI filter designs to meet the EMI requirements before the actual circuit board system layout starts. This module also enables EMI debugging and helps find the best solutions after the hardware is built. In the EMI design suite of PSIM, a generic design template can be used by engineers to go through the typical conducted EMI pre-compliance iteration steps of a converter product development cycle. The template provides the complete set of blocks needed for the design and analysis, namely the LISN, the EMI filter, the signal analyzer, for common block and differential mode, and the parasitic capacitance block. Based on the EMI selected standards, the design suite automatically designs the EMI filter with proper attenuations for both modes, common and differential conduction emission noises. It will generate a complete operational system ready to simulate. Let's see, with Adrien Michel, our power electronics lead engineer, how to use this suite to design a buck converter. In this example, the buck converter has an input voltage of 120 volts, an output voltage of 12 volts, and a power of 250 watts. The parasitic parameters and the common mode parasitic capacitances are defined as described.
Now we have to open PSIM and open the buck converter circuit with the CISPR 22 Class B EMI standard example. We have basically all the power stages. We have the control stages, which is in fact the peak current mode control. We have all the parasitic capacitances and the EMI filter stage. So the EMI performance evaluation can be achieved in the following 3 steps. First, we have to define the system parasitic parameters and some EMI filters parameters. Then we have to run the simulation with the EMI filter disabled and record and enter the frequencies and amplitude for both CM and DM, as well as the EMI standard levels at the worst point where CM and DM exceeds the EMI standard. And finally, we have to perform the EMI filter design and run the simulation again with the EMI filter enabled. For the first simulation, the filter needs to be disabled. So we have also to fill in the Cx, Cy, and RCM values which belongs to the EMI filter itself. Then we can launch the simulation and observe the CM, DM, and EMI signals into SimView. So let's display CM, then DM, and EMI signal. We have to change the y-axis as dB microvolt and click on the FFT button. So let's do this for CM, DM, and EMI. And we have to click on the FFT now. We are going also to modify the x-axis start at 90 kilo. And now we can easily check our results. And now we can observe the CM, DM, and EMI with new axis definitions. And we can easily add an EMI standard filter that we need to compare with. So we can do that for all the signals. And now you can easily observe the result and conclude that the CM, DM, and EMI signals are above the EMI standard. So the simulation won't give any satisfying result because we have too much noises. As we can see here, we are always above our standard. And the first frequency to start with is 200 kilohertz. For troubleshooting this, we have to measure the frequency and amplitude of CM and DM signals and the corresponding EMI standard levels at the point of interest, that is at the lowest frequency with highest noise level above the EMI standard. In our case, the highest CM noise level is 81 dB by microvolt and the highest DM noise level is 81.5 dB by microvolt as well. They both occur at 200 kHz frequency. The EMI standard amplitude is 63.6 dB microvolt. Then we have to enter those values into the parameter panel. Once the values of frequency and amplitude have been filled in the parameter panel, we can also check the EMI filter attenuation button. So this tool provides a convenient way to calculate quickly how much attenuation the design EMI filter will provide to noises at different frequencies. So in this panel, we have to click on the button EMI filter attenuation in order to display the CM and DM EMI noises attenuation from the design EMI filter as shown here. We can clearly identify that dBHCM shows the attenuation of CM noise and dBHDM shows the attenuation of the DM noise both in dB. So one big advantage of the EMI design suite is that the parameters of the EMI filter will be calculated automatically for a given EMI standard, saving users the effort and trouble of designing the EMI filter. We can finally run the simulation with the EMI design filter enabled, so set to 1. And once we run the simulation, once it is completed, we can inspect the CM, DM signals to make sure they are below the EMI standard level. And here, this is exactly the case. However, if we still see some inconsistencies, we can tune the parameters from the user specification input. Now my circuit is in totally compliance with EMI standard and it fulfills at 100% the user specification.
As demonstrated by Adrian, the EMI design suite easily allows you to compare the results obtained with and without the EMI filter. Without the EMI filter, the noise exceeds the standard specifications and the buck converter will not comply the CISPR 22 Class B. On the contrary, when adding our EMI filter we can clearly observe that the noises are mitigated and below the standard requirements. Now our power system is approved for prototyping and can be tested in real conditions. To conclude, the EMI design suite of PSIM software is the best solution to design and simulate EMI filter to speed up EMI pre-compliance process. On top of that, the value of the suite relies on three key benefits. In the early and late design stage, using the EMI design suite will provide a common platform for system, hardware and EMI testing engineers to enable them to communicate and work through the EMI pre-compliance process. The suite also provides a qualitative and step-by-step guidance in EMI analysis and filter design. This add-on module of PSIM also significantly reduces the time necessary for EMI filter design, debugging, and certification processes. If you are interested to get a trial version of the EMI design suite, there are two ways to contact us. By email at sales@powersys-solutions.com or by scanning the QR code and filling in the form.